Everyone, welcome back to the channel. Today we're solving fun and practical problems about counting principles and combinatorics like locks, handshakes, quizzes, and even gut fashion choices. Stay tuned and challenge yourself with each question. Let's try number 1. A combination lock has a dial bearing the numbers 1 through 16. How many different three-number combinations are possible if there are no restrictions on the three numbers? For example, 1654, 1654, 516, 3312 are three different valid combinations. A 48, B 4096, C 3360, or D 256. Now here, each slot has 16 options. And take note, numbers can repeat. For example, in 3312. So, we have how many events? First thing is to know how many events do we have here. Since we're looking for the three number combinations, we have event 1, event 2, event 3. Again, we have 3 events. Now, we need to know how many options do we have per event. Since we have 16 numbers in total, we have 16 options to choose for event 1, 16 for event 2, and for the event 3, that is also 16. All you have to do is to multiply 16, the first event, by the second event, by the third event, or that is 4096. And the answer is letter B. Okay, so there are 4096 different three number combinations that are possible. Notice they called it a combination, but order matters. This is actually a permutation with a repetition. Number 2 problem. Prior to the coin toss for a football game, the captains for the two teams meet at midfield. One team has 3 captains and the other team has 5 captains. Each captain from the first team shakes hands with each captain from the other team. How many handshakes occur? 30, 8, 15, or 17? So again, all you have to do is to know the number of events in this scenario. Now, in our scenario, one team has 3 captains, the other has 5. So we have 2 events, right? So event 1 for the first team and event 2 for the other team. Now let's try to look how many captains are there in each team. So it says in the second statement, one team has 3 captains and the other team has 5 captains. So in order to find the total handshakes, all you have to do is to multiply 3 by 5, and that is 15, letter C. Counting connections, multiply groups, that's the fundamental counting principle. Now let's proceed to the third question. A 7-question quiz has 4 true or false questions, followed by 3 multiple choice questions. For each multiple choice question, there are 4 possible answers. In how many different ways is it possible to answer the 7 questions? A12, B 80, C 28, or the 1024? So this is an example of exam with true or false and multiple choice. Now, if we want to look, how many events do we have? So we have 2 events. So event 1 and event 2. What is event 1? This is for choosing true or false, and for event 2 is for the multiple choice type of questions. Now, we want to know how many options or possible options are there in each event. Okay, since it is said that there are 7 questions. Okay, 4 true or false, and 3 for multiple choice. Now, in a true or false type of test, how many options do we have? There are 2. There are true, namely true or false. Now, in a multiple choice, it is said in the second statement that for each multiple choice question, there are 4 possible answers. So there are 4 possible answers for a multiple choice. But in the true or false, there are 4 questions. So we need to raise these by 4, or that is 2 times 2 times 2 times 2. So 1 true or false, another true or false, another true or false, another true or false, or that is 2 raised to 4. And for the multiple choice type of question, we have 3. So this is raised to 3, or that is 1 multiple choice question, another multiple choice question, and another multiple choice question. And simply multiply. 3 raised to 4 times 4 raised to 3 is 16 times 64, or that is 1024. And the answer is letter D. Each question is a choice. Multiply choices to find total outcomes. Last example. Socrates is going to buy a new motorcycle. The motorcycles that interest him come with the following optional accessories: extra noisy pipes, sidecar, trailer, training wheels. How many different accessory combinations are possible? 16, 8, 24, or 10? So again, so what are the optional accessories? Extra noise pipe, sidecar, trailer, and training wheels. How many options do we have? We have, we have 2 options. Okay, so each accessory, yes or no. Okay, so we have 4, right? So we have 4 options, but so in this, we have only one event. Okay, either to take that accessories or not. So it is a yes or no options. So we have 2 options only. Okay, and it is being raised with 4 because there are 4 optional accessories. So or that is 2 times 2 times 2 times 2. So yes or no for extra noisy pipes, yes or no for sidecar, yes or no for trailer, yes or no for training wheels. So it is optional accessories. So either Socrates take it or not. So how many different accessory combinations are possible? 2 times 2 times 2 times 2, or that is 16, and the answer is letter A. A great job. Counting problems are everywhere, from locks to fashion. If you enjoyed this, smash that like button, subscribe, and comment which problem you want solved next. Permutations, combinations, or probability. Until then, keep counting your possibilities, not your obstacles.